Hello, I am Iman, a cloud support engineer here at the AWS office in Cape Town. Today, I'm going to show you how to configure an Amazon CloudFront distribution to serve an HTTPS request for an Amazon Simple Storage Service bucket. I'll also show you the main differences between a website endpoint and a REST API endpoint in Amazon S3. And I will show you how to use a custom SSL certificate with your CloudFront distribution. Let's get started. First, open the AWS Management Console and navigate to CloudFront. Choose Create Distribution to see a list of settings that we can modify to configure our CloudFront distribution. You can see information icons present next to each setting that gives you a description of what the setting is. Let's start with Origin Domain. For Amazon S3, we see two options to choose from. We can choose the S3 Bucket REST API endpoint from the drop-down list, or we can enter the S3 Bucket's website endpoint manually. Let's go over the key differences between a REST API endpoint and a website endpoint so that you can determine what is best for your use case. The REST API endpoint has benefits in relation to SSL. The REST API endpoint supports end-to-end encryption, origin access identities, and the ability to restrict content to private users. However, depending on the use case, you might want your bucket to be made publicly accessible. In comparison, the website endpoint doesn't support SSL. The website endpoint does allow for redirect functionality. For example, you can use a website endpoint when you want to redirect users from one URL to another. A website endpoint also supports the ability to use a default index object to be served if a user doesn't request a specific object. Note that a website endpoint supports only publicly readable content in your bucket. Because a website endpoint supports only HTTP traffic, I will choose a REST API endpoint to demonstrate an end-to-end HTTPS connection. For the origin path, if you want CloudFront to always request content from a particular directory in the origin, you can enter the directory path beginning with a /. The origin name populates automatically after you select the REST API endpoint from the drop-down list, but you can change it if you need to. For origin access, we have three options. The first option is public. If you choose this option, then the S3 bucket must allow public access. The second option is OAC, or Origin Access Control Settings. This option restricts access to the S3 bucket to authenticated requests from CloudFront only. We recommend using OAC because it supports all Amazon S3 buckets in all regions, including opt-in regions launched after December 2022. Amazon S3 server-side encryption with AWS KMS, SSE KMS, dynamic requests, post, put, etc. to Amazon S3. The third option, OEI, or Origin Access Identity, is now considered legacy as it doesn't support the previously mentioned scenarios or it requires extra workarounds in those scenarios. For this demonstration, we will use the recommended approach and configure OAC. Thus, select the red button Origin Access Control Settings. From the drop-down menu, select your Origin Access Control Settings. If none is created, then select Create Control Settings and then click Create. CloudFront will provide you with a bucket policy after creating the distribution, which you will need to manually apply to your S3 bucket to grant CloudFront permissions. We will address this at the end of the Create Distribution wizard. Once the distribution is created, At the top, a blue ribbon would appear, stating that you will need to update the S3 bucket policy. You can click the Copy Policy button on the right of the ribbon. Thereafter, navigate to the S3 console, then your S3 bucket. Under Permissions, you should find the bucket policy. You can then click Edit and then paste in the bucket policy provided to you by CloudFront, and then click Save Changes. You can add a custom header for CloudFront if you want to include it in all requests that it sends to your origin. Also, you can activate Origin Shield for your distribution if you want. Origin Shield is an additional caching layer that comes with additional costs. By expanding the Additional Settings section, you can refine the default values for connection attempts, connection timeout, in addition to the custom origin-only related settings such as response timeout and keep alive timeout. Under the default cache behavior, you can specify a path pattern to determine the requests that apply to this cache behavior based on the request's URI path. For example, you can apply caching to only .gpj images in a specific folder, while excluding dynamic JavaScript content from this behavior. Note that path patterns are case-sensitive and they support wildcard matching. However, the path pattern doesn't support regex. The Compress Objects Automatically option is set to Yes by default. This setting means that CloudFront compresses certain files that it receives from the origin before delivering them to the viewer. Under the Viewer section, let's select our Viewer Protocol policy. We have three options: HTTP and HTTPS, redirect HTTP to HTTPS, and HTTPS only. For our demo, let's select the second option to make sure that all users are served traffic over HTTPS. Choosing the first option allows HTTP traffic, and the third option blocks all HTTP requests. For allowed HTTP methods, you can select the option that applies to your use case. Under Restrict Viewer Access, you can choose to restrict viewer access either by using CloudFront signed URLs or signed cookies to access your content. Under the cache key and origin requests, it is best practice to use a cache policy and origin request policy to control the cache key and origin requests. You can also choose to use an existing response headers policy or create a new one. You can associate edge functions and CloudFront events with this cache behavior. Under Settings, for the price class for best performance, it is a best practice to use all edge locations. You can optionally associate a WAF firewall (ECL) with your distribution. Next, depending on your use case, you can add an alternate domain name or CNAME or a list of them. If you don't use a custom domain name, CloudFront assigns a default domain name to your distribution. In this case, you can use the default SSL certificate that is already selected and available in the distribution. If you wanted to use a custom domain name, such as www.example.com instead, then you must use a custom SSL certificate that covers the custom domain name that is added to CloudFront. This lets you change the security policy associated to your distribution. If you are using your own domain name with CloudFront, follow these additional steps before you create your distribution. Specify your domain name in the alternate domain name section. Note that you must own the domain and have access to make DNS record updates to serve traffic using the domain. Next, configure the custom SSL certificate. Choose Custom SSL Certificate. Under SSL certificate, you can either request a certificate from AWS Certificate Manager, or you can import a certificate to be used with CloudFront. Note that the certificate must be in US East 1 region to be used with CloudFront. If your certificate is not in the US East 1 region, then you can't use that certificate with CloudFront. If the certificate is imported, it must be issued by a trusted CA. To request a certificate from ECM, navigate to the ECM console and then request a certificate. Add a domain name and then choose DNS or email validation to prove the ownership of the domain. When domain ownership validation is complete, the ECM certificate is issued. From that point, the certificate can be used with CloudFront by selecting it in the distribution configuration. The next step is to update the DNS record to point to the CloudFront distribution CNAME. Note that you can find your distribution's domain name in the CloudFront console. Updating this CNAME record allows content to be served through your custom domain name through CloudFront. You can use Amazon Route 53 to create an alias record. I will show you how to do that. Navigate to the Route 53 console and then choose Hosted Zones. In the Hosted Zone, create a hosted zone that is the name of the domain that you want to route traffic for. For instance, if you wanted to use example.com, enter that here and then choose the Create a Hosted Zone button. After a hosted zone is created, create a record. I will use simple routing. Choose Next, define a simple record for your domain name here. For example, if your domain name is www.example.com, then enter www here. The example.com will be here. Next, toggle the alias button on and choose the endpoint that you want to use. In this case, alias to CloudFront distribution. Choose your distribution here. Choose a simple routing policy and then choose the Create Records button. To use your own domain name, you can use Route 53 to create an alias record that points to your CloudFront distribution. An alias record is a Route 53 extension to DNS. It is similar to a CNAME record, but you can create an alias record for both a root domain such as example.com and the subdomain www.example.com. If you are using another DNS provider, you can create a CNAME record only for subdomains such as www.example.com. CloudFront allows you to choose the HTTP version that is supported between the client and the CloudFront. This means that you can add support for HTTP 3 or 2 depending on your workflow. HTTP 1.1 is supported by default. You can activate standard access logging to log requests and errors to an S3 bucket. Doing so can help you troubleshoot issues that might occur later. You can activate or deactivate IP version 6 support on your distribution. If IP version 6 is deactivated, then the DNS lookup against your distribution won't return IP version 6 addresses. So now you know how to configure an Amazon CloudFront distribution to serve HTTPS requests for an Amazon S3 bucket, the main differences between a website endpoint and a REST API endpoint in Amazon S3, and how to use a custom SSL certificate with your CloudFront distribution. Thanks for watching and happy cloud computing from all of us here at AWS.